Hello, welcome to Quantum Online Maths again. Okay, today we are going to look into the topic called variation. Okay, in variation, we have four different types of variations, but today we are going to zero into direct variation. Okay, we have direct variation, we have inverse variation, we have also joint variation and partial variation. But for today, we are going to look into direct variation and explore direct variation. Okay, we have an example here. You are told, given that y varies directly as x when x is 3 and y is 6. Calculate y when x is 7.5 and x when y is 16. Okay, the word variation is the same thing as proportion. Proportion, okay? What it means, if you have quantities, if you have different quantities, how do they relate? What is the relationship between different quantities? Okay, like x and y, these are quantities. Okay, what is the relationship between them? Okay, so in certain questions they might add more than two variables, but in this case this is direct what variation. Okay, so how do we solve it? I will show you. Okay, it is a very simple question. So by the time we solve one or two questions, you will get acquainted and understand properly what it means to solve direct variation. Let's go. Now, solution. Okay, you need to understand again that in variation, you have to first of all look for the constant of the variation. Okay, the constant of the variation. Now, we are told that x varies as what? Y varies as what? As x. So you put the sign of variation. This is a Greek sign, okay? It's used to represent the sign of variation. You are told that y varies as what? X, okay? In this particular question. So for you to remove this sign, you will introduce a constant. So what this implies is that y is equal to constant k multiplied by what? X. Okay, you see, now we have an equation, but we are told that when that relationship is happening, that x is equal to 3 and y is equal to 6. So in other words, we can say y, which is 6, is equal to what? K multiplied by what? X, which is 3. Okay, so this implies that k is equal to 6 divided by what? 3, which is equal to what? 2. So our constant k is equal to what? 2. Okay, now we were told to calculate y when x is equal to 7.5. Okay, so in other words, we know that y is equal to what? Kx, but we were told to find the value of y when what? When x is equal to 7.5. But we've gotten the value of the constant to be 2. So you have that y is equal to 2 multiplied by what? 7.5. And 2 times 7.5 will give us what? 15. Okay, so y is equal to what? 15 when x is equal to what? 7.5. This is the first solution. Then the second solution, y, we are told to find x when y is equal to 16.5. So we have our what? We have our equation already. Y is equal to what? Kx. So we are told, look for the value of what? X. Now, we were given that y is equal to what? 16.5. Now is equal to 2, which is k, multiplied by what? X. Okay, so you have that 16.5 is equal to what? 2x. So you can say that x is equal to 16.5 divided by what? 2, making x the subject of the equation, which is equal to what? 2 divided by 16, you have 8.2 divided by, you have 25. Okay, so now when x, now x is equal to what? 8.25 when y was given as what? 16.5. Solution. This is the final solution in this problem. As you can see, there is relationship. When this is increasing, the other is increasing as regards direct variation. Thank you for watching. God bless you.